Hello guys and welcome to a Stalker Shadow of Chernobyl running on a laptop, and today I'm going to show you 10K resolution, 8K resolution, 4K resolution running on a laptop with a GTX 1070 Pascal GPU architecture video card equipped with 8GB of GDDR5 and i7 7700HQ CPU, 7th generation quad core 8 threads with 12GB of system RAM. Okay, today I'm running this video on the 8K native screen, 8K resolution native screen, and I'm going to GSR to 10K resolution during this video today. Okay, so we're going to render in 10K resolution, real pixels, guys, in real time, and then we're going to downscale it to 8K resolution native. Okay, so pretty much the performance that you're going to see is going to be the performance out of the 10K resolution screen, plus minus 2 FPS. As you can see, I have at the left top self-explanatory system specs updated every second, which is the VRAM frequency. VRAM frequency today is 8000 megahertz for our GDDR5, 8GB of VRAM frame buffer, and the usage right now is particular second 1843 megabytes of our VRAM. The total VRAM usage can go up to 8,192 megabytes, but sometimes Windows 10 operating system utilizing 128 megabytes, sometimes 256 megabytes pre-cache of that VRAM. So pretty much you don't want to go above 8,000 megabytes, okay, if you're running video cards with 8GB of VRAM. Then I have the GPU temperature, 76 Celsius. Then I have GPU load. We want to have that load as high as possible. The ideal will be 97% or higher than 97%. Then I have the frequency on the GPU, which is 1823 megahertz or 1.8 gigahertz. Then I have the CPU and system RAM specs, which is CPU temperature 79 Celsius. It's loading right now to 13%. As you can see, we want to keep it as low as possible. We don't want to go above 92% on CPU usage. Keep that in mind. If the CPU usage goes above 92%, this is a sign that you need to get a CPU with more cores, okay, at least 2 more extra cores, so you're going to lower your CPU usage. Hopefully that makes sense. My CPU frequency today 3610 megahertz or 3.6 gigahertz. Then I have the system RAM usage, which is 5,883 megabytes. Okay, when we're going to load some data into the VRAM, and when we're going to overload our VRAM, the VRAM will offload some data into the system RAM based on Nvidia drivers, so the game is not going to crash. So when this will happen, the latency delay goes like above 80 milliseconds, and the system RAM usage is becoming very heavy, like you're gonna see it. But keep your eye at the system RAM usage, and right now it's 5,874 megabytes. And then the FPS we want to keep as high as possible. As you can see, I'm running this today on the laptop Asus GL702VS model. And the latency delay in milliseconds before each frame rendered, and pretty much this latency delay caused by the GPU, VRAM, system RAM, CPU, and the software, which is the game engine and the DirectX 9 API in our case. We want to keep it as low as possible. The ideal for any games below 10 milliseconds, it's very comfortable gameplay. But in a lot of classic old school games, below 20 milliseconds, it's still very comfortable gameplay. Hopefully this makes sense, guys. I'm coming in real time. I will try not to edit this video. Don't forget to smash that like button. English is not my first language, but I have a lot of experience since PC hardware enthusiast, PC overclocker, system engineer since 1998. Keep that in mind. So I have a lot of information with you to share. So I'm going to go full dynamic lighting, which is the maximum possible thing, maximum visuals, maximum possible thing. We're going to start with 4K resolution, 16 divided by 9 aspect ratio, and we're going to switch to 8K resolution, 16 divided by 9 aspect ratio, and then 10K resolution. Because the 12K resolution, I'm going to show it to you. Actually, I'm going to show you 12K resolution, but it's going to be unplayable. Today, this video is recorded with Nvidia ShadowPlay software, so please add 3 FPS to the FPS counter if you want to have the FPS without the recording, because during the particular game, it took 3 FPS to record it with the ShadowPlay. Everything will be maxed out, no anti-aliasing though. Oh, actually, I'm going to show you 12K resolution when everything is not maxed out. And we're probably going, after the 4K resolution, we're going to go ahead and check the 12K resolution when everything is not maxed out first. Let's go ahead and do that. Let's go ahead and run this right now. As you can see, 4K resolution. The stats at the left top corner for you. Self-explanatory, as just I already explained it to you. Look at these visuals. But when I'm going to switch to 8K resolution or even 10K resolution, the visuals will be incredible. Every single pixel of every single detail will be visible to us, and it's just looking so incredible, guys. Even 10K on 8K native screen, it looks incredible. It looks much better than 8K resolution for sure. On the 8K resolution, 4K resolution, a little bit to me looking a little bit pixelated, like 1080p for 4K resolution folks in some games. As you can see, this shadow is fixable. This is the radius of the sun and the distance the sun to the landscape, and it's fixable through the console, but we're not gonna do that. This is the default Stalker Shadow of Chernobyl game on Steam, the default game without any modes. So we can compare it and test it with the Titan RTX, with 2 Titan RTX in the future in SLI, with the RTX 2080 Ti, with the 2 RTX 2080 Ti's video cards in SLI, and the future PC hardware, and compare it and find out what is our, things. Look at this. 4K is nice, but at 10K resolution, this asphalt, you can see every single detail, even over there, if you're going to look at. It's not going to be that blurry. It's going to be visible, the pixels, the details. And especially grass will be rendered on another level when we're comparing 10K resolution and 4K resolution, or even 8K resolution and 4K resolution. And it's obvious, guys, but the game looks so amazing when you're running even vanilla version or original Stalker Shadow of Chernobyl on 8K resolution and above. It's just unbelievable. You just want to play it again, and it still looks as a beautiful game, and it is a beautiful game. Okay, as you can see, everything is chicky-picky and dumpy. Hopefully, guys, you like it. Don't forget to smash that like button. So pretty much this is going to be the first video of laptop running Stalker Shadow of Chernobyl on 12K, 10K, and I believe 8K resolution uploaded to the YouTube ever in 2019. Keep that in mind. And only on the GTX 1070 video card that is a Pascal GPU architecture equipped with the 8GB of the VRAM. Okay, that's pretty much it, guys. Let me real quick go ahead and switch it now. I'm going to go ahead and switch it, guys, to 8K resolution real quick, and then I'm going to go ahead and do it to everything maxed out, 8K resolution, and then I'm going to do 10K resolution maxed out as well, and then I'm going to do the 12K resolution not maxed out, so it's not going to be like 1-2 FPS. Without the recording, 12K resolution maxed out is 4 FPS. I just want to let you know. But without the recording, but with the recording, with the ShadowPlay, it's probably going to be 1-2 FPS, and it's not even testable. So I don't want to waste too much of your time on that, because there is no much valuable information. Look how beautiful the game looks like. And especially if you're going to visit x-raysdk.com, my website, where I'm creating my own modes for the Stalker game series. I'm going to create a grass pre-render mode. So over there, you didn't see a grass over there. But with my mode, you will be able to see grass over there. And as you can see, as I'm approaching, the grass is pre-rendering over there, right? But with my mode, it's not going to be pre-rendered. It's already going to be there. And it's going to be there on the hill over there, as you can see, all the way everywhere. And the realism will be on another level. I didn't create any modes yet for Stalker Shadow of Chernobyl, but I will do mini modes. And you want to get my cinematic grass patch by iPlay 4K for the Shadow of Chernobyl for the Stalker Shadow of Chernobyl. I already released for the Call of Pripyat in all kind of different flavors. Go ahead and visit the as again www.x-raysdk.com to download it and try it on Call of Pripyat. But I'm going to do the same thing for the Clear Skies, and I'm going to do the same thing for the Shadow of Chernobyl. And during my X-Ray SDK video tutorials, if I ever will release them, I just need 25 students that I'm going to teach online, and the ticket will cost $1,000, and it's going to be pretty much 10 classes where we're going to discuss how to mod the Stalker and how to create your own games with the X-Ray game engine that is available for free. And the developers released the X-Ray SDK tools for free, but they didn't release the manual. And I believe that I'm the only one English speaking personality from Western Hemisphere that is available, capable, and available to teach you guys how to use the X-Ray SDK and create your own modes or even your own games. But you cannot sell those games because it only can be available as free. But you can start as a game developers using this game engine, and this game engine has an unbelievable landscape rendering. As you can see, it's just photorealistic like there is no other games out there. Buildings and landscape. Alright guys, well, alright, so this was guys with the 8K resolution. 8K resolution is still kind of visible to us, okay, as you can see, and it was of course maxed out. I didn't edit this video. So what we're gonna do now, let me switch back to 4K resolution. Let me switch back to 4K resolution. I believe it's very small over here. It's going to be our 4K resolution, and then I'm going to switch back to 10K resolution and maxed out, just so you're going to see that I exactly switched to 10K resolution, because you're not gonna see it under the 8K resolution, okay? Under the 4K resolution, if you're watching this video at 1080p or 4K, you can see it. But if you're watching this video on the lower resolution devices, you're not gonna see it like 720p. So I decided to go ahead for your convenience. So I'm going to go ahead and select 10,880 pixels by 5,760 pixels. This is going to be the 10K resolution, 16 divided by 9 aspect ratio. Everything will be maxed out. Here we go. I already tested. It's supposed to work, and it does. Look at that. Wow. In the menu it's 86 FPS, but in the game, forget about it. We're gonna load the level of details from the X-Ray game engine. Check it out, guys. Keep your eye at the left top. The FPS is 2 FPS. We overloaded our VRAM. You can tell it by the latency. It's above 80 milliseconds latency delay, and by my formula, I already told you we overloaded our VRAM. So what's going on here? I cannot play it like this, but look at this visuals. Look at the quality of these visuals, guys. Look at these details. Every single texture is showing every single pixel right now to us. It's not like experience at 1080p when the 2-3 pixels merge together into one pixel. You receive more photorealism, you receive more like details to the 3D objects, and it's unbelievable. It's looking great, guys. But it's not ready. It's going to wake up. Right now, as you can see, 3-5 FPS. Without the ShadowPlay recording, it was like 7-8 FPS. So as I told you, 3-4 FPS, you gotta add to the left top corner to the FPS to get the FPS recording without the ShadowPlay recording. So it's kind of playable without ShadowPlay recording, but it's not playable with the ShadowPlay recording. Keep that in mind. Okay, so what I'm gonna do, I'm going to lower the details a little bit. And I'm going to say, okay, this is the 10K resolution. As you can see, the menu is not ready. If you're a game developer, never develop aesthetic menus. All the time, user interface should be dynamic and scaling to the user screen resolution. Keep that in mind in a game. So it's going to be automatic and everything will be visible. Font, sliders, everything. So when you're designing user interface, you got to keep this in mind. Okay, guys? So I'm going to decrease the visual distance. I'm going to go ahead and do everything on medium. How about that? Everything will be at medium. This is, I believe this is at medium, like that. Everything at medium in the center, like that. This slider can go here. Okay, I believe medium will be a little bit more to that, but as you can see, okay, to over here, this is the medium. But this slider doesn't go that way. This slider doesn't go this way. Um, like that. Lighting distance like that. So this is the DirectX 9. Completely maxed out visuals, guys. And it's going to help us. You will see it's going to help us. And the 10K resolution is not going to be that visible in terms of horrible quality of the visuals, because the texture still will be pumping that sharpness to us, even if they're low quality. They're still going to be nice. They're still going to render every single pixel of that low quality. Okay. Okay, guys. Still FPS is high. Didn't help. So we're pretty much overloading our VRAM right now. So 8 gigabytes is not enough above 8K resolution, as you can see. High latency delay, check out at our system RAM load, 6900 megabytes, and our VRAM is like 7730 megabyte, jump back to 6900 megabyte, jump back to 4258 megabytes. So it's kind of mess. It's like uploading a lot of data into the system RAM, and this is what causing that. And without the ShadowPlay recording, I'm capable to play a 10K resolution maxed out. With the ShadowPlay recording, I'm not, but we're going to test everything with the ShadowPlay recording, so I'm not capable. Let's go ahead and create everything at medium, everything at low, and it should help to our VRAM usage. Or maybe I should shut down the game and reboot it again, and maybe we just overload it just because we're switching between multiple resolutions, 8K, 4K, 10K. It caused that. Could be a possibility. So everything at low right now. Higher FPS, as you can see. Okay, so that means that we offloaded some data from the system RAM and right now storing it properly into the VRAM. But as again, it's dropping a lot. It's dropping a lot, but the visuals are incredible. So 8 gigabyte of VRAM, guys, to be honest with you, because the Nvidia driver is offloading the data from VRAM into the system RAM, is still considered by me as the cheating, because it's downgrading our performance dramatically when it does it, because 2400 megahertz DDR4 in this laptop is not fast enough as 8000 megahertz in our VRAM frequency, and it's 4 times slower, and this is what's causing that. It's causing, as you can see, horrible performance, but the visuals are incredible even when everything at low. Guys, keep in mind that I'm going to record Titan RTX single video card here, and I'm pretty sure we're going to go ahead and bring it to 16K resolution if it's possible in Stalker Shadow of Chernobyl game engine, which is the earliest X-ray game engines. I'm pretty sure that 12K resolution is possible with the Stalker Call of Pripyat, because I was running 12K resolution with the RTX 2080 Ti Stalker Call of Pripyat during my test. But it was heavily VRAM overload, even that 11 gigabyte of VRAM overload. So I'm pretty sure there is a possibility that 16K resolution will be possible, but we're going to find out. I will try to test all the 3 games, guys. All right, that's it, guys. That's pretty much it. And let me real quick go ahead and close the game and go with you over the specs that we were running today. So this was running, guys, on the laptop with GTX 1070 video card that is faster than GTX 1070 in the desktop. And let me real quick show you why this GTX 1070 is faster than GTX 1070 in laptops. It's easy to answer, and right here under the GPU, It has 2048 CUDA cores, okay, and the desktop version GTX 1070 has 1920 CUDA cores and 128 TMU units for this laptop GTX 1070, or it's still the full GTX 1070. It's just the better revision, the last revision, and the desktop version has 120 TMU units. So technically, we're 3% faster on the hardware level than GTX 1070 in the desktop, but just because this laptop is running so hot, and any gaming laptop will be running so hot without the thermal repasting of the thermal compound to liquid metal. Otherwise, any other thermal compounds will be running so hot. Only liquid metal can lower your temperature on a CPU by 10 Celsius and on GPU by 10 Celsius because it's connected with the same copper pipes, okay, the heat sinks on the CPU and GPU. So keep that in mind. And yeah, this pretty beautiful laptop, as you can see, that was available for sale in 2016. It's one of my mobile units for anything, and yeah, I'm using it because it's similar performance to GTX 980 Ti video cards. Keep that in mind. Similar, and Titan X Maxwell GPU architecture will be similar performance, but Titan X Maxwell GPU architecture will have no problem to render 10K resolution at maximum visuals, and probably 12K resolution at maximum visuals, because Titan X Maxwell GPU architecture has 12 gigabyte of VRAM. Okay, guys? And we pretty much was limited here by our VRAM, but not by the GPU. Keep that in mind. All right. As you can see, 16K resolution is maximum 3D surface renderable under the DirectX API, and 32K for the textures. Okay, 2D textures under the DirectX API. OpenGL will be kind of similar to that, and stuff like that. And yeah, thank you so much, guys, for watching. I play 4K. Right now I'm putting some great videos for you to check out. Go ahead and check it out, and don't forget to smash that like button for the support to motivate me to create more great videos, and subscribe, smash that the bell button, and share it with your friends, guys. Cool videos are coming right now on the screen. If not, they're on the screen. Go ahead and check the video description, and I will see you in the next videos. Have a great day. Till the next time. Peace.